Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Isobutene, 2-methylpropene, CH2 is equal to C, CH3, 2 undergoes acid-catalyzed dimerization in the presence of H2SO4. The mechanism involves protonation of isobutene to form a carbocation, followed by addition to another molecule of isobutene and then elimination. Moving on to the next step. H2SO4 protonates isobutene to give the tert-butyl carbocation CH3, 3C+. This tertiary carbocation adds to the double bond of a second molecule of isobutene, CH2 is equal to C, CH3, 2 at the terminal carbon, Markovnikov addition, giving CH3, 3C, CH2 C+, CH3, 2, which is a tertiary carbocation at C2 of the adduct. Moving on to the next step. This C8 tertiary carbocation undergoes elimination, loss of a proton. The proton can be lost from the CH2 group adjacent to the positive center, giving CH3, 3C, CH2 C, CH3 is equal to CH2, option B, or from the methyl group on the cationic carbon, giving CH3, 3C, CH is equal to C, CH3, CH3. Wait, rearrangement-free elimination from CH3, 3C, CH2 C+, CH3, 2 loss of H from the CH2 gives CH3, 3C, CH is equal to C, CH3, 2. But that is not shown. Loss of H from one of the terminal CH3 groups of C+, CH3, 2 gives CH3, 3C, CH2 C, CH3 is equal to CH2, which is option B. And for the final step, option A would require a hydride or methyl shift. The direct elimination product from the tertiary carbocation CH3, 3C, CH2 C+, CH3, 2 without rearrangement by loss of a proton from the terminal methyl gives the less substituted terminal alkene B2, 4, 4-trimethylpent 1Na. Loss of proton from the CH2 group gives 2, 4, 4-trimethylpent 2Na. However, in industrial and acid-catalyzed isobutene dimerization, the terminal alkene B is indeed formed as a significant product. The major product observed experimentally from H2SO4 catalyzed dimerization of isobutene is 2, 4, 4-trimethylpent 1Na, option B, along with 2, 4, 4-trimethylpent 2Na, with the 1Na, option B, being the one identified as the answer here. Option A is 2, 4, 4-trimethylpent 2Na and could also form but is not the answer given. Options C and D involve different carbon skeletons not consistent with direct tert-butyl cation addition to isobutene without rearrangement to a different skeleton. They represent different connectivity and are minor or unlikely products. Therefore, the correct answer is B. Therefore, the correct answer is option B.